ladies and gentlemen, fellow classmates, teachers, and counselors. My name is Richard.
My name is Chongyu.
My name is Christine.
And today we're presenting you with the NCCR, which stands for the Nanoscale Cancer Recognition Robot. Talking about cancer, you may wonder, what is cancer? Well, you're in luck. Cancer is basically a disease that is caused by malfunctionings in the replication process of genetic information, or DNA. It causes an uncontrollable cell division of abnormal cells in different parts of the body. And once it reaches the bloodstream, it has the potential to spread to any other parts of your body.
Well, according to statistics, there's an increasing number of people get cancer in recent years. About 39% of men and women will be diagnosed with as cancer during their lives.
So nowadays, we've developed several available therapies for treating cancer. The major therapies are surgical therapy and chemotherapy. For example, chemotherapy is a category of cancer treatment that uses one or more anti-cancer drugs as part of the standardized chemotherapy treatment, or it may aim to prolong life or to reduce symptoms. However, despite their successes, they all have disadvantages. For example, the problem of the chemotherapy is that there are no chemical drugs that recognizes only cancer cells. Instead, it kills cancer cells and also normal cells. Chemotherapy will shorten the survival of patients over time.
As you can see, we have provided you with an exclusive video of a biology class 200 years from now.
Good morning, students. How are you doing?
We're doing great, Mr. Circlebeard.
Today, children, we're going to learn about the development and history of nanotechnology.
Yay!
About 200 years ago, in human civilization, there was a life-threatening disease that affected every family.
What? A disease?
Yes, a disease that was very deadly called cancer. At one point, it affected more than 41% of the population. Now, repeat after me. Cancer.
Cancer.
No, cancer.
Cancer.
Children, cancer is a very deadly disease and affects a lot of people. But it's still not as devastating as my mixtape! However, in the year 2138, nano-engineers have developed a nanoscale robot that prevents tumor and cancer cells from developing. This nanobot works by detecting cancer cells and injecting doxorubicin into their bodies at a very early stage of development. Nowadays, everyone is vaccinated with this device at birth to prevent us from getting cancer. Well, children, I guess it's recess. Go outside and have fun.
Oh, just so you guys know, the roof was fine.
Yeah, I didn't hear about that.
Sorry. So in the near future, we're gonna develop the nanoscale cancer recognition robot. It's basically an advanced robot that recognizes and terminates developing cancer cells. So it's in the size of about 3 microns, where the average cell is about 5 microns. And just so you know, every micron is actually 0.001 millimeter. And just to give you an idea, that's one. Wait, hold on. Just so you know, your hair, every piece of your hair, the diameter is actually 0.889 millimeters, so it's super tiny. Oh yeah, and the basic mechanics. Just like the hepatitis B1, which we are injected injected into our body at birth, it is a the nanobot is basically a artificially made vaccine that can be injected into the bloodstream to monitor and scan your body for cancer. The nanobot will attach to the cancer cell, and it will inject chemotherapy drugs into the cell, which will lead to the termination of the cancer cell. And the drug we're using is doxorubicin. It's basically a bacterial antibiotic that is widely used to treat leukemia and various other forms of cancer. You may ask, but how do we find these unpredictable cancer cells? Well, again, you're in luck, because our device provides 4 different types of recognition devices.
Well, as you know, the cancer cells has a huge difference from normal cells. So we want to create a powerful camera so the robot can easily distinguish and recognize these cancer cells. That is a 3D eye-shaped camera. Well, our camera has the most important advantages is it has a special sensor. We simulate the structure of the retina of our eyes, and which is a hemisphere. And it is a curved surface, not like a traditional sensor, which is a flat surface. So by this technology, we can have a wider visual angle, and the robot can not only see a small rectangular view in front of it, it can even detect the object at the corner of its view. And also, by the 5 pairs of camera at different position of this robot, we can sense a 360 degrees of the view, which exceedingly enhance our ability to detect the cancer cells. Well, our second characteristics is it has 2 lenses for each camera, and you can look at the diagram. Each of the lenses can know the direction of the object. So you can draw 2 lines, and you can calculate the exact position of the cancer cells. So we can not only know the direction of the cells, but also the distance. And that would be very easier for the robot to land on the cells and inject the chemicals. Well, our second technology is legs with tactile sensor. Well, as you know, the texture of the cancer cells is quite different from the normal cells. So we want to create a device to find the difference. And we install the touch sensor to the legs. When the robot lands on the cells, it can touch the surface and can further determine whether it is cancer cells.
We also applied the sonar technology. Sonar, it's short for sound navigation and ranging. It's helpful for exploring and mapping in any type of liquid, especially in the ocean, but we can also apply it in the bloodstream because sound waves travel further in water and faster in water than do like radar and just light. Active sonar transducers emit an acoustic signals of pulse of sound into the water. If an object is in the path of the sound pulse, the sound bounces off the objects and reflects an echo of the sound to the sound transducer. If the transducer is equipped with the ability to receive signals, it measures the strength of the signal by determining the time between the emission of the sound pulse and its reception. The transducer can also determine the range and orientation of the object. As you all may know, our immune cells cannot penetrate other cells, which may be infected with virus or bacteria, and in this case, it's cancer. Thus, they rely on information conveyed by fragments of intracellular components being presented on major histocompatibility, I think I'm pronouncing it right, histocompatibility complex, which is MHC, molecules on the cell surface. Well, MHC basically acts like a handshake to confirm if it is like a harmful cell or a healthy cell. In a normal cell, it's basically a firm handshake, like with the immune system. However, like on cancer cells, they have like a slightly modified handshake that the immune system cannot actually identify. That's why cancer cells developed so easily. And so in our system, we can actually recognize the difference in the MHC cells of healthy cells and the cancer So, yeah.
Well, currently, cancer is one of the world's most severe disease. So, if we can eradicate it by our nano robots, millions of people's lives can be saved, and humans' longevity can be exceedingly extended. Well, ladies and gentlemen, a world without cancer is coming. Thank you.